Hello, welcome back. Welcome back to the channel. Welcome back to another video. Welcome to math. All right, starting with a joke. How do snails fight? They slug it out. Okay. So today we're gonna talk about it's part of further graphs. We're gonna look in particular about reciprocals and asymptotes. Okay. Reciprocals, you've done this a million times before in primary. If I said, or even like maybe year 7, year 8, if I had 1/4, right? If I wanted to reciprocal that, it'll be 4/1, and then it'll be a total of 4. It's just a flipping of the fraction. Same deal here. If I have the reciprocal of fx, it's just going to be 1 on fx. Boom. All right. Now this is also using our indice law. It can also be written as fx, and then that whole thing gets raised to the power of -1 because that's what a negative index does. Okay, now sometimes reciprocals are helpful because they help kind of to undo certain functions. And so what we need to learn how to do is if we're given a function, we need to learn how to sketch the reciprocal. Okay, now reciprocals often result in asymptotes. Okay, now of asymptote, if you've forgotten, it's a value that a graph will approach but never reach. So in this case here, this dotted line that I'm drawing for the hyperbola, that there is an asymptote, which that's a vertical asymptote. But then we also have one more here that's sometimes a bit harder to see because sometimes we have that x-axis, but there's also a horizontal asymptote here. And many graphs will often have either multiple vertical or some horizontal, and sometimes both, a mixture. Okay, now asymptotes, why they're important is they're going to be super important to help us graph things out. Okay, they almost tell us where things go and how they end up. So we need to find how to test for asymptotes. Now, vertically, they're a little bit easier. They happen at undefined sections, or in other words, when the denominator equals to 0. Okay, so any fraction and there's an unknown at the bottom, that expression cannot equal 0. And where it does equal to 0, that's where your asymptote is. Okay, and in general, when we're talking about horizontal asymptotes, we kind of remember that any fraction that has a non-zero numerator can't equal 0. Okay, so that tells us that, okay, there's probably going to be an asymptote there. Okay, horizontal asymptote. Now, let's break down a question that we might be asked to do. We might be asked to sketch y equals 1 on 2 plus x. Okay, so we're not going to talk too much about reciprocals yet. For the moment, we're just going to examine what it's like to find some asymptotes and sketch it. Okay, first things first, find the vertical asymptote. Remember that happens, and I'll use red so it stands out here. Find the vertical asymptote. The way we do that is by letting the denominator equal 0 and solving for x. So remember, 2 plus x, that's our denominator, and it cannot equal to 0. You cannot have 0 as your denominator. So if I was to kind of do this, x would equal to -2. That there's your vertical asymptote. Now I'm going to start putting things down as I go. So I know that there's going to be a vertical asymptote at x equals to -2. Okay. Now horizontal asymptote. I know here that 1 on 2 plus x cannot equal 0. Any fraction, no matter what I put there as the value of x, that fraction will never be 0. It can be undefined, but it will never be 0. Okay, so in that case here, should have done this in red as well, but that's fine. My y equals to 0. That's going to be my horizontal asymptote. Now I'm just going to do it slightly above so you can see it, but it will be technically right on the line. Okay, now I realized I also missed B. Let's hop over to B. Now here is a helpful tool. Some of you guys may know this as a table of values. I'm going to call it a table of signs just because I don't care so much about the value. I care more about the sign, meaning is it positive or negative? Okay, that's all I'm looking for. So which values am I going to use? Well, I know that something happens at x equals -2. I know it's undefined, right? So it's undefined, right? And so my sign is nothing, undefined, doesn't exist. So let's pick a value towards the left of it. Let's pick -3, and let's pick any value that's kind of to the right or greater than -2. I'm going to pick 0 just to make things easy for me. Okay, so if I go that, now what I'll do is I'll substitute it into here. If I have, if that's x, then y would be 1/2 plus -3. So that's just going to be, in this case, -1. Okay, if I look on the right-hand side, if I substitute in 0 for x, y would be 1/2 plus 0, which is just half. Now, all I'm looking for is the sign. Now, for the sign on this side, we've got negative, and to the right of the undefined area, we have positive. So this is just a way, I don't need to do the bottom layer, but I just need you to see that all I care about is it positive, is it negative? Okay, now that I've got that, that's almost basically all the information that we kind of need. Okay, now I've got these asymptotes, which my graph is going to approach but never reach. And I know that to the left, right? So wherever -3 would be, to the left of that asymptote of the -2, I know that I'm going to be negative. So it doesn't make sense that I'd be above. I would have to be below. And the only line I can kind of draw that would approach both asymptotes would look like this. Okay, now we know that to the right of that x equals -2, we know that we're positive. So that tells me that, okay, I'm kind of going to look like this, right? And that would be how you would roughly sketch the curve. Okay, now there's a lot of information missing, but as long as I know roughly what it looks like and roughly where it goes, for now, I'm happy. Okay, is that making sense? I don't know why I'm asking. I think it's just I ask as a teacher, but whatever. Now, this is where I'm going to lose a lot of you guys. Okay, now I'm going to go through this, explain it the best I can, pause it, write these down, try to make sense of them. Now, when you're sketching your reciprocals, now we're going to get to the sketching part and giving you a normal function and then sketching the reciprocal, right? Guideline number 1 is your new graph has the same sign for all x. So that means if it was positive in the original graph, it's also going to be positive in your reciprocal graph. Okay. Now, part 2 is probably going to be your most important one. It's going to be, if I say zeros, so that means, in other words, all the x-intercepts of your function are going to now be your asymptotes for your reciprocal function. Okay. Again, I'll show you what that means. Now, 3 is just a helpful one. Now, if your function will tend to either positive or negative infinity as x increases or decreases, you're going to have an x, your x-axis is a horizontal asymptote. In other words, x or y equals 0, that's going to give your horizontal asymptote. Also, if your y equals positive or -1 in your original function, then it's also going to be the same thing in your reciprocal function, because 1 and -1, when you take the reciprocal, it's still the same. And then part 5 is just a helpful one. If your fx has a local max, your reciprocal will have a local min at the same or a similar value. Okay. Now, now, for most of you guys, probably was like, what the heck is all that information? TLDR, too long, didn't read. What I want you to do is, when we're graphing reciprocal functions, I want you to sketch in the asymptotes, which means you have to know where they are. Sketch in the asymptotes and then copy the signs. Okay, now let me show you some examples before I lose you guys. Remember, sketch in the asymptotes, copy the signs. Okay, this is an example. Sketch the reciprocal function given the original function. So I'm going to call this one, that's our original. And what I want to do is I want to sketch the reciprocal function. So the first thing I want to do is I want to find, where are my zeros? Where are my x-intercepts? I can see that I've got an x-intercept at 4, an x-intercept at 0, and another x-intercept at 4. So that means here x equals -4. I'm going to have a asymptote. All right. Now, again, I'm also going to have another asymptote at x equals 0. I'm also going to have another one at x equals +4. Now, see how I've immediately bunched these up, or I've already kind of made a whole bunch of asymptotes. Now, we also know that as they tend towards infinity in either direction, it's actually going to go to infinity. So what that means is we have this y equals 0 asymptote as well. So now, as you can kind of see, we're kind of split into 1, 2, 3, 4, 5, 6, 7, 8 different sections that we cannot cross into. They cannot cross those lines. We've got 8 separate sections now. All I need to do is find out how it works. So if I was to do something very similar here, now this is the part. I've sketched in the asymptotes. Now all I want to do now is copy the signs. So again, if I was to draw these sections here, I draw it in the wrong place. Now all it is this, the sign doesn't change. So that means if I look at this first section here, it's positive. So that tells me, okay, I have to be in the positive quadrant. I'm not going to be below the x-axis. I'm actually going to be above. Okay, now if I look at this second one, the second kind of like column, so to speak. In this second column here, in my original graph, I'm actually below the x-axis. So in the reciprocal, I'm actually also going to be below. But because of the way that it's bounded, I'm going to end up having a graph that looks a little bit like this in this section. Okay, now if I go to the third column, okay, in the third column here, I can definitely see I'm positive. And again, because I'm bound by these asymptotes, that's how my function ends up looking. Okay, now the last one, in this fourth kind of quadrant or fourth, I don't know, column, so to speak, I'm negative. So then I can kind of see, okay, I must be negative. Now, if you need to stop that, rewind it, play it again, make sure you're understanding that, okay, how did I draw in the asymptotes? And how did I know which shape or which way everything would go? Okay. Now, if you're happy with that, I've got one more example, slightly different. Okay, now we've got this kind of function. It's going to look a little bit weirder. Okay, first things first. Do I see any asymptotes? Yes. I can see that because I cut through the x-axis once, I'm going to have one asymptote exactly where it cuts. Right, and again, it should be dead straight on the line, but I just want you to see that that's the asymptote there. But now I've also got 2 horizontal asymptotes. And so what I'm going to do here is that tells me that I now have horizontal asymptotes as well. Now, where my horizontal asymptotes are going to take is they're going to be the reciprocal versions of those. So if y equals to 2, my y reciprocal should be 1/2. And if my y equals to -2, which is kind of like that bottom asymptote we have on the left-hand side, your inverse, or not your inverse, sorry, your reciprocal function would now be 1/2. Now, these are going to end up being our new, excuse the drawing, but these are going to be our new asymptotes. I'm just going to pretend that I've drawn this correctly. So that's now y equals to 1/2, and that's y equals -1/2. Okay. So because of my horizontal asymptotes and because they've been taken the reciprocal of, we've taken the reciprocal. And we've made 2 into 1/2 and -2 into -1/2. Okay, now again, all I need to do now is look at the very, very similar things. Let's look at column number, let's look at column number 1. Okay, so just everything towards the right. Okay, towards the right-hand side of the y-axis. So here we can see that our graph is actually positive, right? It's above the x-axis. So that tells us that we're also going to be above, and that tells me that we're actually going to live in this section up here. Okay. Now on the left-hand side of that vertical asymptote, we're below the x-axis in our original function, right? Our original function is fx. So now our fx, all in the power of the -1, it's going to be this guy here because it's below the x-axis. Okay, and that there would end up becoming our reciprocal function, fx -1. Okay, hopefully that makes a little bit of sense, and hopefully that helps with your work. It's been good having you. I'll catch you guys later. All right, bye-bye.